In this video, we're going to be diving into throttling and debouncing, and I'm going to be using a lot of visual examples to help you learn the difference between the two, as well as showing you how you can implement them in JavaScript, including multiple implementations of throttle, so you can see all the different ways that you can use this in your code for various different needs that you have. Welcome back to WebDevSimplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. And before we start diving into the code, I first want us to understand what the differences between debouncing and throttling are and why you may want to use them. So here we have a bunch of events that are occurring at a second-based interval. So at second 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So as you can see, we're triggering an event at second 1, 2, 3, 7, 8, and 12. So this is when our events are occurring. And if you don't do any debouncing or throttling, then you're going to essentially trigger whatever that event is at that exact time. So at 1 second, 2 seconds, 3 seconds, 7, 8, and 12, we're going to be doing whatever that event wants us to do. But oftentimes you may have a lot of events that get triggered in a very short period of time, and you don't want all of those events to happen at the same time. For example, if you're moving around the mouse, you don't want to trigger an event every single time you move the mouse, because that could happen hundreds of times a second. And if you're calling an API that's doing something hundreds of times a second, you're easily going to get throttled and rate limited by that API, which is not at all what you want. So this is where debouncing and throttling come in, and they're slightly different. First, I want to take a look at debounce. So for debounce, what essentially happens is you set a timer. In our case, we have a 2-second timer. And all that says is there needs to be a 2-second delay after your event before it actually fires. And if we look here, we're using our exact same events, 1, 2, 3, 7, 8, and 12. And you can see at second 1, we have an event that has this red circle around it. And that's because it is an event that was waiting to be triggered, but never actually happened because we had another event that occurred within that 2-second window. So if you have a delay of 2 seconds in our case, and you have one event that happens at second 1 and another event that happens 1 second later, the very first event gets canceled before it even gets triggered. You can see here at 2 seconds, we have another event that was fired off, but again, this one's red because it was never triggered. Finally, at second 3, you can see we have this event, and this one has a blue circle around it, and that's to indicate that, again, this is an event that at second 3 was queued in and said, okay, if in 2 seconds nothing else has happened, then I'm going to trigger this event. And you can see 2 seconds later at second 5, that event was triggered. So with debounce, you always have essentially a delay of whatever your delay is before your event triggers. So if you have a 1 second delay, it's going to wait 1 second after your event before it can actually trigger. And any time that you have less than that 1 second delay between different events, whatever the first event is going to be canceled. So you can see here these first 2 events were canceled because there was not a long enough delay before the next event. But this event that occurred at second 3 had 2 seconds to wait, and you can see it actually executed that event at second number 5. Same exact thing here. You can see this 7 event was canceled, but 8 was queued and it ran at 10 seconds. And same thing here, 12 was then ran at 14 seconds. So again, we had that 2-second delay. Now throttling is actually luckily a little bit easier to understand, and the way that throttling works is essentially you can run at most one event during that period, which in our case is 2 seconds. So every 2 seconds is the most frequently we can run events. So you can see here at second 1, we don't have any events that we ran yet, so we trigger this one immediately. Then at second 2, we try to run an event, but it hasn't been 2 seconds since our first event. It's only been 1 second, so it is obviously within our throttle limit, so we just ignore it completely. Then when we get to second number 3, it has been 2 seconds since the first event, so we can render out an event just fine, so it runs this event. Then when we get all the way to second number 7, you can see here again, it has been way more than 2 seconds since the last event, so we render this out just fine. And then of course, the next one is trying to be rendered long before it actually can. It's only a 1 second delay here instead of the 2 seconds, so we completely skip this one. And then finally, you can see at second 12, again, it's been more than 2 seconds since our event at 7 seconds, so it renders that event just fine. And that's kind of how throttling works. Essentially, at most, you can run one event during that period of time, which in our case is 2 seconds. Now, we have a much more in-depth visual example to kind of show what this looks like, and that's going to be over here. So if I just give this a refresh, you can see on the right-hand side, I have these counters that are coming across, so 1 second, 2 second, 3 second, 4 second, and every single time I click my mouse, it's going to try to trigger an event. And you can see here, a blue event that is a solid blue like this means the event was triggered immediately right then. If I have a partial blue event, as you can see here, this one is kind of like an opaque blue event. That means it is waiting to be triggered, and as soon as I get to my debounce timeout, which in this case is 1 second, so 1 second later, that event then goes solid blue to say that it was actually successfully ran. And if I have a red event, for example, if I try to fire off a bunch of events, you can see that I'm getting these red ones. These are events that were completely skipped and not ran at all. So you can see in the normal case, these events are ran really, really quick back to back. If we go into the debounce state, as long as I keep clicking, it's never going to run my event until I have a 1 second delay between clicks, and then you can see it runs that event. And if we look at the throttle example, essentially it runs an event every single 1 second at most. So you can see here, as I'm clicking, pretty much on the 1 second mark, it's able to run the next event. And that's pretty much what the code on the left-hand side of our screen is doing. It is inside of this visualizer function, this class right here. Now I'm not going to dive super deep into exactly what this does, but if you do want to see the code for all of this, it's going to be linked in a GitHub down in the description below, so you can check out all the code for it if you want to. But I'm mostly going to be focusing on how do we actually write debounce and throttle so that we can use them in this text section right here. So you can see I'm incrementing the text every single time I run an event, and I only want to increment the text inside of here based on when I debounce or when I throttle, and I want to use various different techniques for throttling. And the first thing we're going to implement though besides throttling is actually going to be debounce, because it's quite a bit easier to implement than throttle, even though it's maybe a little more difficult to wrap your head around. So we're going to create a brand new file right here. We're going to call this debounce.js, and we're just going to export a function from this called debounce. And inside this function, what we're essentially going to do is we're going to call a callback, which is the function we want to call, and we're going to specify a delay for that function that we want. So in our case, we have a callback and we have a delay, just like that. Now, the reason I'm creating this function like this is because essentially what we're going to do inside of here is we're going to create a debounced version of increment text. So I can say debounce increment is going to be equal to calling that debounce function that we just created. I'm going to pass it in the function we want to call, which in our case is increment text, and then I'm going to pass it in my delay, which in our case is going to be 1 second. So we essentially created a debounced version of this function that I can call just like my normal function. So up here, I essentially want to call debounce increment and pass it in my debounce text section. So essentially I want this function to call the increment text function, but only within that debounce period. So let's actually implement that debounce function, because right now you can see things are broken because we haven't actually implemented what this function is supposed to look like. So what we can do is we can go ahead inside of here, and I can say that I want to return a function, and this function is just going to take in whatever arguments it takes. It doesn't really matter what those arguments are. And then what we're going to do is we're going to create a timeout. So we can say set timeout. That timeout is going to have a delay that is going to be equal to our delay. And then we're going to call some function inside of here. So we can just call whatever function we want inside of here. And this function is just going to be our callback function with all of our arguments. Now, normally you would call the function like this, and that is going to work just fine. Let me make sure this is an arrow function first. There we go. And that's going to work just fine if we do that. But the problem with doing it this way is that the this binding could get messed up. So to make sure that we fix any this bindings and stuff like that, an easier way to do this would be to just call apply, and then we can pass in this as well as our args. And what that's going to do is essentially make sure that the this binding is properly passed along to our callback. That way, if we're using this inside of that callback function, it should work just fine without any issues. So that's all we need to do to actually call that function. If you did it the other way where you just called it with the arguments, it works fine for 99% of cases, so it's not a huge deal. Now, this is most of the way to getting our debounce function finished, but the one problem is that we're essentially calling this after a 1 second delay, but we're not canceling out any of the previous ones. To show you what that looks like, if we look at this debounce section down here, every time I click, you'll see that this increments 1 second later. So if I click 1 second later, it increments. But if I click like 5 times, you can see it increments those 1 second later for each one of them, which is obviously not what we want. We want to cancel out all of the ones that occur between our debounce period. So to do that, we just need to keep track of our timeout. So we can just say timeout ID like this. And then down here, we can say that our timeout ID is equal to that. And we want to clear out our timeout from our timeout ID every single time we call this. So now every single time we call this function, if there's a current timeout going on, it's going to cancel that timeout and restart a brand new one. So it always starts a brand new fresh 1 second timer. And if that timer eventually finishes with nothing else occurring, then it calls this callback. So if I just click a bunch of times, you can see debounce is never being called. And eventually, after a 1 second delay of me clicking, you can see this debounce is incremented by 1, as long as there's a 1 second period delay between when I click and when the next click is. So you may be wondering when exactly you would want to use debounce. And by far the most popular use case for debounce is when you're calling out to an API based on different user input. A very common example is a search box. Is someone who's typing into a search box, for example, they're typing in the name of a movie and they type in matrix like this. If you're calling an API every single time they enter a key, for example, to try to get them a dynamic list of results every single time they enter a key, in the case of typing in matrix, that's 6 different times that you had to call your API in a relatively short period of time. And your user doesn't really care what the movie list result is for M or MA or MIT. They only care what it looks like when they fully type in the word matrix. So to be able to save yourself resources on the backend, as well as to save your user the extra data of calling your API a bunch of times, you can set this up in a debounce, where essentially you say, I only want to call this API after there's been a 250 millisecond delay in them typing in this input. And that would look something like this. You could just say document.add event listener, and this is going to be the input event listener because we have like some type of input event, just like that. And then normally what you would do is you would call the function inside of here, call API, whatever it is, but instead you would wrap that inside of a debounce. So we would have a debounce API just like this. This would have that call API, and we would put something like 250 milliseconds inside of here. So now we can use that up here instead. And essentially what this does is as long as there's a 250 millisecond delay between that user's input, it'll call out to the API. Otherwise, it won't do anything. So it doesn't matter how much they type into the input. It's not going to make any extra calls to the API unless they actually have a delay, and then it'll give them back those responses. So this is something that's very common when you're doing things like autocomplete and search inputs and user input like that. So let's go ahead and save these files, get them back to what we had before. And now I want to talk about throttling, because throttling is slightly different than debounce, as we already saw, and the use cases for it are slightly different. And there's lots of different ways to implement throttle as well to do different things with it. We're going to start with the most basic and then move on to some more advanced ones. So let's create our throttle.js function. We're going to export throttle from here, just like that. And we're going to actually call this basic throttle because this is going to be the most basic version of throttling something. And the actual implementation of this throttle function is really not too complicated. It's actually very similar to how we did debounce. So I'm going to copy that over, make sure we get our callback and our delay, and then we're going to come in here and actually fine tune this to make it work like we want. So essentially what we wanted to do is if there's no throttling happening at all, I want to immediately call my function. So up here, I'm going to just keep track of if we are throttled or not. I'm going to set that to false by default. Then we can come down here with an if check and I can say, hey, if I am throttled, then just return. Don't do anything at all because I am currently being throttled. Otherwise, if I'm not currently being throttled, for example, the first time I call this function, then I want to call my callback and do all that stuff by applying the arguments and so on. So we can come in here, apply our different arguments. Then what we can do is we can set a timeout for our delay, and all that timeout is going to do is it's going to take is throttled and it's going to set it to false. And here we're going to set is throttled equal to true. So essentially all this code does is says, if I'm throttled, don't do anything at all. If I'm not throttled, call my function, set the throttle equal to true so we don't have any more calls come through, and then 1 second later, reset that throttle back to false. That way I can come back in here and call this function again. So you can see it's a very simple approach that essentially allows you to only run this function up to one time within the time period that's allotted. So now if we go back into our script, we can set up a throttled version of this as well. So we can just say throttle, and we're going to use that basic throttle function on increment text, and we're going to do the same exact 1 second delay. So now I can say throttle increment on my throttle text, and now we should be able to see the difference between debounce and throttle on this text section down here. So if I click a bunch of times, you can see essentially every single 1 second, it's allowing me to increment that number. So as long as I wait at least 1 second and click, it's going to be incrementing that throttle number. And if I click a bunch of times in between, all of those are completely ignored until we get to that 1 second period since the last one was executed. Now there are quite a few problems with this method, and you can actually see it in our visualization quite well. If I click 3 times, for example, let's just do that real quick. I click a bunch of times. You'll notice that the very last time that I clicked doesn't actually get ran. Essentially, I click and then I click a bunch of times, and then let's say I do all those clicks in 500 milliseconds. You would think that after 500 more milliseconds, when I get to the end of that 1 second delay, it would take whatever my last click was and run that. That is an alternative thing that you can do inside of throttling, and it's sometimes called a trailing edge. Essentially, you take the very last event that you had that was supposed to run but was skipped, and instead you now run that after a whatever delay that you have. I actually have this built into the visualizer, and then we're going to create the function for it. So we can come in here and we can say that our throttle method here is going to be equal to trailing. So now if I give that a save, and you'll notice when I click a bunch of times that eventually what's going to happen is that very last one that is being ran eventually turns blue, because essentially it's taken the very last one that was skipped, and at the very end of the waiting period, if there is one that was skipped, it will run that in the throttle. So you can see here, if I wait a long time and then click, it just immediately runs. But if I have a bunch of them queued up, it'll take that last one and it'll run it automatically at the end of that 1 second delay. So what we want to do is we want to implement our own version of that inside of here. So I'm going to copy this up. I'm going to come down here and I'm going to call this the throttle, or we'll just say trailing throttle. This is going to be very similar to what we had before, but with one big difference, and that's that we want to keep track of what the last thing that we tried to run was while we were in the throttled state. So we can just say last event is going to be equal to nothing at all. So we'll just leave that completely blank. And then down here, instead of immediately returning, what we want to do is we want to take our last event But we just want to set that equal to an object that is going to contain all the different stuff we need. So it's going to contain our arguments, and it's going to contain our context, which is just the this keyword. That way we can keep access to the same this keyword, and we can keep access to all the different arguments that we pass into this function. So all we're doing here is just keeping track of whatever the last event that we ran was while we're in that throttled state. Then down here, when we're going to set throttle equal to false, we just want to do a simple check to see, do we have a last event? If we have a last event, then we want to run that last event by just saying callback.apply last event.args. And actually this will be last event.context right here. So we can get the context passed along as well as all the different arguments passed along. Otherwise, what we want to do is we just want to set throttle equal to false. But of course, if we actually run this function, we now need to reset our timer to reset our throttle, because essentially what we did is we tried to run this particular piece of code, and we ran this code with a brand new event, so we need to restart our timer back at that 1 second. So I'm going to actually take all the code inside here and break it out into its own function. We'll just come up here and we'll just say reset timer or something like that. It doesn't really matter what this is called. Let's just clean that up a little bit, just like that. And now we can use this down here. So essentially our code hasn't changed. We're just moved around where our reset timer is at. And all I want to do inside of here is now set my last event equal to null, so that we have no last event. So essentially if we have a last event, I want to run that, and then we're going to reset our timer. So we're going to say set timeout. That's going to be called reset timer and delay, just like that. And actually we should probably set this to like reset throttle. It's a little bit better name. So let's use that in all these different places. So again, the code down here is essentially the same as before. We don't even need to worry about that timer ID. So I will remove that from our code because we're not actually using that anywhere. There we go. So what we're essentially doing is same thing, callback. We're going to set its throttled, and then we're going to reset our throttled. If we haven't had any last events at all, you can see the code works exactly the same as it before. But now if we have a event that was our last event, what we're going to do is we're going to run that event immediately when our timeout finishes, and then we're going to restart our timeout, essentially permanently keeping us in that throttled state. That way we can then keep track of our next last event if we have one. So let's go ahead and use that instead. So here we're going to have our trailing throttle, just like that. And let's see exactly how this works. You can see if I click a bunch of times and wait, you'll notice that this increments up to 2. And if we look at our model here for our visualization, you can see essentially that last one, even though it was in that delay period, eventually ran once that delay period ended. You can see if I click a bunch of times, if there's no delay or anything like that, you can see it's still going once per second. But as soon as I stop, that last one will execute as soon as it gets to the end of that delay. Now the final more advanced type of throttle is going to be a queue-based throttle, where you don't actually ignore any events at all. You execute every single event that comes to you. You just make sure that there's a delay between each of those events. And to do that, we're going to use the queue method instead. So here I'm just going to click a bunch of times, and you'll notice after 1 second, essentially it's going through and it's queuing up the next job in line until it eventually finishes all the different jobs that it has. And if there's items in the queue, when I try to in-queue more items, you can see that they just continually wait, and it's always starting with the oldest event until it gets all the way through the events. Now, this is something that's really useful if you essentially want to make sure every event that comes through gets executed, but you want to make sure you don't overload things by calling too many different events at once. Obviously, a big downside of this is if you queue up a ton of events and you have a rather long delay, obviously your system could get incredibly backed up, and new events are going to take a very, very long time to get through the system. So you have to make sure you balance your system with this particular approach to make sure that it's going to work perfectly fine for you and that you don't overload it with too many events all at once. So let's go ahead and implement that queuing version of our throttling. It's actually not nearly as difficult as you may think, and it's going to work very similar to our trailing throttle, but instead of a single event, we're keeping track of all the events we have. So here we're just going to call this our queue throttle. And then instead of keeping track of our last event, instead what we're going to do is we're going to have a queue that is set to an empty array by default. Then we can kind of ignore this reset throttle. We'll come back to this in a little bit. Down here, if we are currently throttled, what I want to do is I want to take my queue and I just want to add on to it. And essentially I want to add on all my arguments, and I want to add my context information. So essentially I'm storing the exact same information that I stored up here. As you can see right here, it's the exact same information. I'm just putting it in an array instead of using like I did before. Then down here, I can still call my process throttle or reset throttle. I'm going to call this process queue though, just to be a little bit more of what the name is, because essentially when my timeout finishes, I want to go back through and process everything that was queued up in the time that I was waiting. So up here, I'm going to call this process queue, and in here, we're going to call this process queue as well. Now inside this process queue, instead of checking for the last event, what I need to do is I need to check to see if our queue.length is equal to 0. That essentially means I have nothing at all queued up, so I want to take my isThrottle, set that to false, and I'm just going to return here so I don't have to worry about anything else. So that essentially takes care of this else condition down here. Now the next step is to essentially apply whatever the next item in my queue is, and then set a timeout to process my queue again to hopefully get the next item and the next item and the next item until I get all the way through my different items. So what I can do here is I can say that I want to get my args and my context, and that's going to come from queue.shift. And essentially what shift does is it gets me the very first element in my array. So whatever the first thing I add to my array is, it's going to remove that for me. So always it's getting the oldest event inside of my array. Then what I can do is I can take those args and I can take that context just like this, and I can pass that along to the apply function just like that. And now you can see I've essentially been able to set up my queue. I ran the next event, and then I'm setting my timeout to run the next one. And shift is really nice because it actually removes the element from the array. So this makes my array one shorter, removes that first element, I do all my stuff on it, and now I set my timeout, and my queue is now one element shorter, but I'm making sure I still keep track of anything that happens while I'm currently throttled. The only time I become unthrottled is when my queue is completely empty. So let's go ahead and see if that actually works. We can come into here. We can use the queue throttle version. And now I'm going to click 5 different times, 1, 2, 3, 4, 5. And you'll see here this throttle will slowly increment up until it gets to 5 with 1 second delays between each of the different events that it triggers out. And this is really nice because now you're making sure every event that comes in actually gets processed and ran, which in many situations is what you want to do. So let's talk about when you would want to actually use throttling versus debouncing. We talked about how debounce is really great for when you're like calling out to external things such as an API and you want to wait till all the different data is being compiled before you send out that API call to limit the responses that you need to do. Throttling is really great when you have something that's executing a lot of times and you want to limit the amount of times that that thing is executed. In our case, one thing that you really commonly will do is, for example, if you have a scroll event listener or a mouse event listener, throttling is a really useful technique for that. We can actually do that real quick by just changing this from click. I'm going to change this to mouse move, just like that. And I'm going to only do the ones down here. I'm not going to do the visualizer because that'll add way too many dots to the screen. But you can see as I move my mouse, I'm getting hundreds of different events called in this normal section right here, which is obviously, I don't want to call my functions that many times because it could really slow down the page. But you can see throttle is only calling once every single second. Now currently I have a queue-based throttle, which is probably not what you would want. You probably want a basic throttle like this, so that way you can see essentially once every second it's calling out to this function, but as soon as I stop moving my mouse, it doesn't call this function any more times, so it's only calling it while I'm actively moving my mouse for that 1 second period. So essentially it's limiting the amount of times that I actually call this function. So either a basic or a trailing edge version is probably what you want in this particular case. Now, when it comes to queue-based ones, that's really great for when you're calling out to an API, or maybe your API is being called by someone and you want to make sure that you limit the amount of requests that person can make. You can throttle the requests that are coming in or the requests going out, whatever you're trying to do, to make sure that you don't send too many requests or process too many requests at once. But since you want to make sure you still process all the data that gets passed in, you can put them inside of a queue and slowly process them over time to make sure if you have a surge of events, it doesn't overload your system, but eventually you'll still process through all of those events. A great example would be if you have a email sending service and you want to send emails to people. Well, generally you have 1,000 people on your list, let's say. You don't want to send all 1,000 emails at once. Instead, you want to send maybe 10 emails a second until you're done with that queue. So you're going to send one email every 100 milliseconds until that queue is completely done. So even though 1,000 items get added all at once, it's going to process them one by one until it's done with the entire list. Now that pretty much wraps up the difference between debounce and throttle, but if you want to check out this code to be able to see how these debounce and throttle functions work, as well as to check out that visualizer code, I'm going to link everything in the description in a GitHub repository. With that said, thank you very much for watching and have a good day.